What would happen if a grain of sand approaching the speed of light crashed into Earth? According to the theory of special relativity, the faster an object moves, the greater its mass and energy become. Once the speed approaches the speed of light, its mass tends toward infinity. Now, let's assume that this grain of sand could reach 99% of the speed of light. At this point, its mass would increase dramatically, making its destructive power comparable to that of an asteroid striking the Earth. When it enters Earth's atmosphere, its speed would be so great that it wouldn't explode during flight. Instead, it would instantly light up the night sky due to the intense frictional heat, ionizing the surrounding atmosphere and triggering massive lightning. At the same time, the ozone layer would be torn apart, creating a hole that leaves the Earth vulnerable to dangerous solar radiation and ultraviolet rays. The grain of sand would continue its rapid descent, hurtling toward the center of the Southern Ocean. Upon contact with the ocean's surface, all of its kinetic energy would be released as an extremely devastating force. The energy released would be equivalent to more than 20,000 Hiroshima atomic bombs exploding simultaneously. This release would not only boil and evaporate vast amounts of seawater, but the brightness of the explosion would also penetrate deep into the ocean, making the waters within a 50-kilometer radius appear crystal clear. Despite the grain of sand slowing down due to the resistance of water and rock layers, the energy released would still cause violent shifts in tectonic plates, triggering massive tsunamis. The large-scale evaporation of seawater would create enormous storm clouds, leading to global rainfall. In the following days, as the temperature of the Southern Ocean continued to rise, Antarctic glaciers would begin to melt, causing sea levels to rise, flooding all coastal cities. Simultaneously, the violent tectonic movements would cause global earthquakes and volcanic eruptions. Ash clouds would fill the sky, blocking out sunlight and preventing plants from photosynthesizing. At that point, human civilization might be on the brink of extinction. However, the energy required to completely destroy the Earth is still far greater than this scenario. Scientists estimate that the energy required to fully obliterate Earth is approximately 2.24 times 10 to the power of 32 joules. According to the kinetic energy formula in relativity, only if a grain of sand were infinitely close to the speed of light could it completely destroy the planet. This concept, similar to the weaponry of advanced civilizations used to eliminate lower-level civilizations' coordinates in the three-body problem, is known as light force. That being said, Earth possesses an incredible capacity for self-repair. Over the next few months, volcanic ash would gradually disperse, allowing plants to regrow and produce abundant fresh oxygen, breathing new life into the planet. Eventually, Earth would once again flourish, becoming a vibrant and green home.